Greetings and good morning to my lecturer and also my fellow classmates who are currently attending shipping management course. Today, myself as Manik Muran, follow with my three fellow groupmates would be Ayman Haris, Mohammad Khair Haji, Mohammad Ayman Fikri. We would like to present our presentation, which is evaluating sea rail intermodal efficiency, basically a case study of Troy's Riveris port. Port of Troy's Riveris has several challenges, which are five major challenges they were facing. And the first challenge would be rail network shortcomings, hinder transport shares, and also major problems at specific rail crossings, and also some wagon transit restriction, which led to increase in congestion. Urban environments impede capacity expansion and flexibility, and also cargo flow and transportation bottlenecks. These challenges have actually impact on their daily operation, which were congestion and flow reduction due to rail and transit issues, difficulty in integrating new terminal infrastructure, and also need for innovative solution to balance port and urban interests. And the strategic objectives which have been carried out to reduce the challenge were planned to build a new terminal to reduce traffic jams and improve cargo flow. Meanwhile, addressing integration challenge with current infrastructure, last but not least, focus on sustained capacity and performance improvement. As for background of our study, the port of Troyes Rivers on the St. Lawrence River in Quebec is a key maritime gateway linking inland market to international shipping routes. Its strategic location supports manufacturing, agriculture, and resource exploitation. By facilitating efficient goods movement, it boosts regional economic development and global trade connectivity.
For the problem segment is the restriction on the maximum capacity of wagons allowed in the port and the limitation on entry and exit time, which hinder the movement of wagons into the system and exacerbate bottlenecks. The second one is the time required to move wagons from the train yard to loading unloading point, as well as the time needed to load and unload the wagons impact the overall speed of cargo movement within the port. And the third one is the amount of cargo being processed, which influence storage facility occupancy and overall system load, leading to congestion. And for the analysis is the railway lines use meter gauge, narrow gauge, which limit the ability of providing the double stack container service. Trains on approaches to the port railway junctions are investigated because of the absence of settling path in the railway subsystem of the ports. The wagons awaiting submission to the berth occupy the way of the sorting parks. This is the reason for the inefficient use of rolling stock and increased operating costs. The establishment of optimal parameters for the transfer movement, namely the number of trains, the size of their trains, is based on the following recommendation. For the selected sorting distribution option in the junction, it is necessary to determine the number of wagons transferred when disturbing flows from one unit of the junction to another, and for these trains to establish the optimal dimensions of the movement of the transfer trains as well as the required number of locomotives for servicing them.
For the solution is develop a dynamic capacity management system that adjusts the low number of wagons based on the real-time condition and the demands. This could prevent bottlenecks by ensuring that the port operates at optimal capacity without exceeding limits. So the second is to reduce the time, develop standardized and efficient workflow for loading and unloading operation. This could involve pre-planning, cargo placement, optimized stacking arrangement, and ensuring quick access to cargo within wagons. So the last is forecasting to utilize historical data and predictive analytics to forecast cargo volume more accurately. This will help in anticipating peak periods and adjusting capacity accordingly.
The conclusion, our study focused on optimizing cargo transportation between maritime and rail network. By doing so, we aim to enhance operational effectiveness and economic competitiveness. So the challenges and objective: port authorities globally face challenges in balancing cargo throughput with operational efficiency. Our study identified these challenges and sets clear objectives to improve capacity, utilization, and operational effectiveness. To evaluate Sea Rail intermodal system, we employ a combination of qualitative and quantitative approaches. We particularly focus on achieving operational equilibrium in terminal operation to ensure efficient cargo flow. The solution identified in our study have the potential to streamline operation, reduce cost, and evaluate service level. This not only benefit individual port but also enhance their competitiveness in global trade logistics. So recommendation for the future, as we look to the future, our research suggests exploring innovative strategies for intermodal transport. Investment in infrastructure and technology integration will be key to improving system efficiency. Collaboration among rail and maritime stakeholders is vital for sustainable progress. So what we can conclude, in conclusion, optimizing sea rail intermodal efficiency is critical for sustainable logistics and economic growth. By addressing operational challenges and embracing innovative solutions, we can create a more efficient and interconnected transportation network. Thank you.